Hello everyone. In the previous session, we discussed about sum of product and the product of some form. And we also talked about what are the advantages of minimization of any function. Now we need to discuss something related to the dual of expression and the self dual, how we can find the dual of any function. Suppose any function is given, then if I have to find that the dual of that function or the self dual of that function, so definitely we need to follow certain rules and regulations. So basically, if we have any theorem of the Boolean algebra for one type of operation, then that operation can be converted into the another type of operation, and for that purpose we must follow some of the rules and the regulations, and we need to see what those rules and regulations are. First regulation is, if any expression is written in the form of end, if ending is there, then I have to convert it into the or form. Okay, I just told you, I think previous in the previous lecture. Okay, and vice versa. If end is there, then I have to convert into the or form, and or is converted into the end form. Second point that you should remember, if it is in the NAND form, then I have to convert it into the NOR form. Okay. Third point is, if output is at logical 1, then I need to convert it into the 0 and vice versa. And the fourth and very important point is the keep the variables as it is. Okay, so these are the 4 points that you should consider before finding the dual of any expression. Okay, so let us consider some example. You will be able to understand what is the meaning of this one. Okay, so let us assume I have a function which is written something like, let us assume a b c complement plus a bar bc plus abc. Okay, let us assume I have a function something like this, and if I have to find the dual of this one, then how we can get it? Okay, let us discuss one by one. What it says, ending must be converted into the or, and NAND must be converted into the NOR, and vice versa. Okay, so how we can do that? Here, see, replace all the dot with the plus and plus with the dot. Okay, this is the first step. So that will give you a, yeah, and last point is, keep the variable as it is. I have variable a, so I need to write as it is a. Here I had dot, so I need to write plus a plus b plus c complement. This is the first thing. I need to replace this plus with the dot, so that will be like a bar plus b plus c into a plus b plus c. So this is the dual of the expression. Okay, and this is how we can find the dual of expression. This is very easy, not tough. Okay, so you can convert it. Okay, let us take one more example. Yeah, because initially I considered the SOP form, and after finding the dual, I got in the POS form. Let us do it opposite. Okay, so suppose I have a function which is like this. Let us assume f is equal to a plus b bar plus c, a plus b plus c bar into a plus b plus c. So this is the, let us assume this is the expression which is in the POS form. Now let us try to find the dual of this expression. How to do that? Okay, if I have to find the dual of this one, so follow the same procedure. Replace dot with plus and plus with the dot and keep the variable as it is. So it will become a b bar c plus a b c bar plus a b c. So this is the dual of this one. Now one important thing that we should consider, can we further minimize this one? Even after finding the dual, can we minimize this variable further so that the number of logical gate requirement will also reduce? So let us try to see here. If you see here, this one, a b bar c, a b c bar is here, so and a b c is also here, right? So what we can do, we can simply make some of the variable common here. A b c bar, a b c is there, so what we can do, we can simply make a b common, okay, and c bar plus c, that will give you 1, so a b will come out from here, okay. And similarly, like a b c bar is there, then you can take something out from here and there and you can minimize it, okay. So let us try to minimize it further. How we can do that? If you see here, in the first variable, in the first minterm, I have a b bar c, and if you see here, I have, see here I have a b c, here I have a b bar c, here I have a b c bar, okay. If you see, something is common in first and third minterm, a and c is common, only b and b bar is changed. If you see second and third, here a and b is common and c bar is different, okay. So to simplify these functions, what we can do further, we know that a plus a is nothing but this is a, okay. A plus a is nothing but it is a. So what we can do, because this a b c is common, if I'm making the pairing with this one or with this one, this can be the common term. So I can use a plus b plus c 2 times, and that will not impact the logic function. So let us try to say a b bar c plus a b c plus a b c bar plus a b c. So I have used a b c 2 times because a plus a is 1. A plus a is always a. Okay. So this is how we can get it. If we try to find the common term, so from here, first two terms, a and c are common, so ac will come out and b bar plus b will be here, and if you see here, ab will come out and c plus c bar will be there. So b plus b bar, that will give you 1, and c plus c bar, that will give you 1. So here I will get ac plus ab, and this is the minimized form. So even after finding the dual, I was getting expression something like this, but if we try to minimize it, I will get the expression something like this. So the total cost can also be reduced, like total number of gates can further be reduced even after finding the dual, okay. So this is something that you should know about the dual. One more thing, there are some functions where if I'm finding the dual, then the same function becomes like the output becomes the same function whatever it was before. So those kind of duals are called self dual, okay. So let us take some example on the self dual and try to understand what is the meaning of this one, okay. Okay. So what self dual says, suppose I have a function f, okay, and if I am finding the dual of the function, so this will be same as whatever the function we had before. Okay, so function is not going to be changed. So let us consider some example. What are the some circuits, some of the expression which can give you the self dual? Okay, so suppose I have a function f is equal to let us assume a b plus bc plus ac. Okay, let us assume I have a function like this, and now I need to find the dual of this one first. Okay, if I find the dual of this one, I will get a plus b into b plus c into a plus c. Okay, and we know that if we see closely here, like in these first two terms, a plus b, b plus c, b and b are common in both, so I can write it as a b plus ac. So this is the formula, this is the law which we have already discussed. So a plus b into b plus c can be replaced with the b plus ac. Okay, and this is multiplied with the a plus c. Okay, if we expand this one, so I will get ab plus a into c. So ab plus bc plus AAC plus ACC. Okay, so this is what AAC, that is nothing but this is the AC, and ACC, this is also AC, and AC plus AC, that will give the AC. Okay, so in summary, I will get AB plus BC plus AC. And if we see here, after simplifying, whatever the final expression I have, this is same as what it was before. So these kind of functions are known as self-dual. Okay. So this is important. So this is how we can call them. These are the self-dual. Okay. So this was one of the operations. Now we previously we discussed about the some of the complement and the complement of some form. Like we know that the De Morgan's theorem, we saw like two De Morgan's theorems are there, where one statement says that the sum of the sum of the complement is same as the product of sum of the complement is same as the product of sorry, I missed that. Sum like a bar plus b bar, sum of the complement is same as the complement of product. Yeah, so this is the statement, and vice versa, like we can do it the both the way. Okay. And this is what the De Morgan theorem says. Okay. So let us try to see how we can find the complement form. Complement form is really very important. Complement is nothing but simply like if you have a function f, okay, something like a plus bc, something like that. So complement means f complement, that is simply a plus bc complement. So this is what the complement, the meaning of complement is. But suppose I have a very long expression. Okay, let us assume I have an expression something like f is equal to abc plus a b bar c plus ac b bar, something like that. So if I have to find the complement, so I need to find whole complement and I need to minimize it. Okay, so that may take more time. Okay, so if I will follow some of the regulation to find the complement of any function, then you can easily do it without too much Boolean function simplification. Okay, Boolean algebra solution. So directly you can do that. And how we can do that? Let us try to see it. Okay, so certain rules and regulations are there to find the complement. The first regulation or first point is replace AND operation with the OR operation, which is same as the duality. Second, yeah, similarly for the NAND one. Okay, NAND with the NOR. And yeah, so this dot product can be replaced with the plus and plus with the dot. 1 will be replaced with the 0 and 0 will be replaced with the 1. And the third and very important point, which is different than the duality one, in the duality what we saw, in duality, keep the variable as it is. This was the point which we need to consider, especially in the dual of expression. But if I have to find the complement of expression, in that case, complement each variable. Previously, I was keeping all the variable as it is. I was not changing anything. Okay, but if I have to find the complement, so I need to find the complement of each variable. Okay, complement of each variable is required. So let us take some example and try to understand how we can find the complement of any function and how it is different from the duality. Okay, suppose I have a function. Let us assume it is f. F is equal to, let us assume it is a b c, something like a b c plus a bar b c plus a b bar c bar, any function. Suppose I have this function, and if I have to find the complement of this one, f bar, so f bar is nothing but follow the same relation. A, so here a b c will be replaced with the a bar plus b bar plus c bar. Okay, a bar plus b bar plus c bar. So a bar plus b bar plus c bar into a plus b bar plus c bar into a bar plus b plus c, and this is the complement of the function. Directly you can find the complement like this. Okay, so this is the easiest way to find the complement of any function if you have any. Yeah, if the number of variables are very less, like 1, 2 or something like that, or only few minterms are present, so directly you can do it. You can simply, without knowing any formula, you can do it. But if you have more number of minterm or maxterm and more variables, in that case you need to apply this formula to find the complement of that function. Okay, so this is how easily you can find the complement of any function.
Excuse me, sir.
Yes, please.
So demorganizing a function is same as finding complement?
Demorganizing it, no, it is different. Let us see how it is different. De Morgan's theorem says that, let us assume a plus b complement is same as a complement plus b complement. Here it is like this. Okay, let us assume this side. Okay, so if I am finding the complement of this one, so how the complement will look like? It will be like a dot b. This will be the complement. Is this sorry, I missed a plus b. Yeah, so this is what, like a plus b complement is equal to a complement dot b complement. This is the De Morgan's theorem. So if we try to find the complement of this function, like let us assume a bar dot b bar, so I will get a plus b. And if you see here, a plus b is not same as this one. Okay, so demorganization is not same as the complement form. Both are different.
What if we find the complement?
Yeah, so see, complement. So see, after complementing, if you are finding again complement, so that, so complement of complement, what it means? It means that see, let me repeat again. Here, this is the expression what we got after complementing, right? After applying this formula. Now, if I'm again finding the complement of this one, so this could be like a bar dot b bar. The same thing comes. I am not getting this term. Okay, to get this term, I don't need to complement it again. First do once first I need to complement, then I have to pass it through an inverter. Okay, after passing through it through an inverter, I will get a plus b bar. Okay, yeah, sometimes we use this term for changing the logic, just to use the complement. Okay, so inverting is simply just like a complement, it's not a problem. But yeah, this is the direct way to find the complement, but complement of complement, that will give you something like this. So this kind of complement is based on the formula what we discussed here, and this complement is based on simply just passing through an inverter. Okay, but this is not applicable for all the time, right? So suppose there are some variable, because this was very simple, so you was able to do it. There was something, let us assume there is some function a plus ab bar, something like that. Let us assume after finding the complement, I was getting something like this, let us assume. So if I will pass this through an inverter, I will get a plus ab complement to the complement. The expression will be something like this. So dehomogenization does not say like that. Dehomogenization means simply to, like here, if you see here, I have a plus b complement, where this min term or the max term is dependent one, like a plus b, and then after I have to find the complement. Okay, now they becomes the dependent. And if you see here, a bar is the independent variable and b bar is the dependent variable. So to make them independent, we need to dehomogenize. Okay, so we need to break them, and this is the difference between complementing and the dehomogenizing. You got the answer, or there is doubt somewhere here and there?
Sir, it's clear.
Okay, no, in case any doubt, please let me know. I will explain that thing again. Okay, so this is how we can differentiate the dehomogenization and the complement form.